Welcome back. So today we're going to be working on page 285, which is 9.3 similar right triangles. We're working with this orange foldable. So before we actually go into the foldable, we are going to talk about geometric mean and what that actually means for us. So just here on the outside, I have the geometric mean of two positive numbers, a and b, is the positive number x that satisfies our proportion a over x equals x over b. So then when we cross multiply here, we get x squared equals ab, and then we're going to do the square root of both sides, which gives us x equals the square root of ab. So what this means, if I'm trying to find the geometric mean of two numbers, so I'm going to find the geometric mean of 24 and 48. So then when I set up my proportion, I'm going to have 24 over x equals x over 48. Okay. All right, so next I'm going to cross multiply. So I get x squared equals 24 times 48. And this is 1,152. So now I'm going to take the square root of both of these. And I don't know the square root of 1,152. So I'm going to have to look for my perfect squares and figure out which ones of those will go in there. So I get x equals, there's a ton of them and you can list them. So if you wanted to, we can start over here and say 1,152 and break this down. 4 will go in there. I believe it's 288. 9 will go in there. And you can list them on down. So then we end up finding out that 576 will go in there. And that goes in there 2 times. 576. The square root of 576 is a perfect square. So if you didn't know that one, you can always start with these smaller ones and be able to then continue to break down those larger numbers into smaller and smaller pieces, the ones that you do know. So we have 576 here, and the square root of 2. 576 is 24. So we're going to have 24 square root of 2 equals our x. I do not want decimal approximations. Okay, I want a simplified radical. So we have to continue to practice on this piece. Okay, but what I want to focus on today is the geometric mean part. So we're setting up those proportions and solving. Okay, so again, if I want the geometric mean of 24 and 48, my x is going to go here. That's the geometric mean. My numbers that I'm finding the geometric mean of is going to go in the top left and the bottom right corners. Okay? All right. So now we're going to go inside. Now, if you remember in our last unit, we were talking about similar triangles. So we are going to continue talking about similar triangles, but we're going to focus specifically on right triangles. Okay? Because we've started talking about right triangles in this unit with our Pythagorean theorem. And so now we're going to combine those two. Okay, so if we look here on this first part, we're going to start with example 1. So when we're talking about right triangles, if we have an altitude, now remember altitude means height, so that means it's perpendicular to our base. So in this case, our base is going to be the hypotenuse of a right triangle. So when we have an altitude that is perpendicular to our hypotenuse, then it breaks the triangle up into similar triangles. So this medium-sized triangle and this tiny triangle are similar to my big triangle that I'm starting with. Okay? All right, so what that means for us is we can now set up proportions for our corresponding sides. So that's what geometric mean is coming from. That's where these kind of all fit together. Is we talked about setting up proportional sides. Now we're going to apply that to something new to be able to find some different pieces. Okay, so for this one, something that you might want to do is you can draw 3 triangles. So I'm going to set them up so that they all are sitting with the same orientation and they just get smaller. And then I'm going to label the vertices, so that makes it easier for me to be able to figure out which sides correspond with each other. So for the big one, my right angle is at B, the long leg is A, and the short leg ends at C. Okay, I'm going to do the same thing for the next one, the medium-sized one. My right angle is at D, my short leg ends at B, and my long leg ends at A. For the little one, I have my right angle is at D again, my short leg ends at C, and my long leg ends at B. So now that they're all sitting looking the exact same direction and orientated the same way, it's easier to be able to compare them and find the corresponding parts. So for example 1, we know that the top sides belong to the same triangle. We also know that the bottom sides belong to the same triangle. So BD and CD have to belong to the same triangle. Well, the only triangle that contains both BD and CD is this little one. So this is the little. Okay? So then the next thing I'm going to look at is from top to bottom, these have to be corresponding pieces. So BD on the little one is the long leg. That's this one here. So it has to correspond to AB. So I'm going to look here across the bottom, the long legs, and I see that the long leg on the big one is AB. So this is the large. Okay. So then CD on my little one, that's the short leg, corresponds to the short leg on the large one, and that's CB. So I'm going to put CB here. Okay. All right, now I know this may be a little bit confusing, so bear with me. As we go through these, hopefully it'll become clearer as we move through the examples. For this next one, we are going to switch this. The KJ is in the wrong position, so we're going to move him down here. We're just going to move him to the bottom. Okay, so the same idea here. You can draw your 3 triangles. So I'm going to draw 1, 2, 3. They don't have to be great triangles, just 3 triangles that are all sitting in the same direction so that it makes them easier to compare. Okay, so on this first one, that's my bigger one. So my right angle is at J. And then my 2 sides, these look to be about the same. So I'm just going to turn this triangle to the side so that my right angle comes down here. So that means K goes up at the top, I goes down here at the bottom. Looking at the next one, I'm going to go here. So L is at the right angle. So then I'm just rotating this. So I is going to be at the top and J is going to be at the bottom. The next one is here. I'm just going to turn him a little bit so that L is here on the bottom left, K is going to go in that position, and J is right there. Okay. All right, so again, I'm going to be looking across to see what triangle I'm looking at first. I have an LK and a KJ. So if I look at these triangles, I have a KJ here, but no LK. I have an LJ, an IL, and a JI. So I don't have any of those here. So I'm looking for LK and KJ. LK and KJ. So I found them. So that's the small one. Or we'll call this one number 3. Okay. All right, so I'm looking at this one. Now I'm looking for JL to LK. So LK here, that's my bottom. And I'm looking for JL. So JL is the second one. So this one's number 2. Okay, so now I'm going to come over here and KJ is my hypotenuse. So then I need the hypotenuse of the second one. The hypotenuse is IJ. So this is going to be IJ. All right, so again, we're just setting up our proportions so that then we would be able to solve if we had numbers. All right, so then on this last one, again, I'm going to make my 3 triangles. All right. Okay, so starting with the big one, I have F is at my right angle. And you're just sketching these. They don't have to be anything great. E is the end of my short leg, and G is the end of my long leg. Okay, so then on the medium-sized one, H is my right angle. F is the end of the short leg. G is the end of the long leg. And on the little one, H is still at my right angle. E is the end of my short leg. And F is the end of the long leg. Okay, so I'm going to start here. I have EH and FH. What triangle are both of those pieces on? EH and FH is on the little. Okay, so now I'm going to look from EH. EH is my short leg. Now I need to find FH that's also a short leg here. So it's not the big one. It's going to be the middle. Okay, so that's my FH. So then I'm going to look at FH on my little. That's the long leg, so that corresponds with GH on the middle. Okay, keep in mind that each one of these sides that we're using, they're just about appearing twice. So it's really important that we draw out these 3 triangles so that way we can keep them organized as to which one belongs with which piece. And the other thing is, you'll notice on each of these I put large to little, number 2 to number 3, little to middle. I labeled them to identify which triangle I'm talking about top, which triangle I'm talking about on the bottom, so I didn't confuse them. Okay? All right, so let's keep going. Now we're going to add in some numbers. So looking here at number 4, I'm going to do the same thing. I want 3 triangles to start with so that it's easier for me to identify corresponding pieces. So I'm going to say 36 is my first piece. The 36 corresponds with what piece on what triangle? Well, it's the hypotenuse of my big triangle. So I'm going to put the 36 as the hypotenuse on my big triangle. Now I'm going to look at the X. What does the X correspond to? The X is the short leg on my little triangle. So I'm going to put the X at the position for the short leg of my little one. And then the 12. The 12 corresponds with the short leg of my big triangle, but it's also the hypotenuse of my little triangle. I'm putting 12 in both of those spots. Okay, so now I'm going to set up my proportion. Now, if you remember, we had the 2 that were the same. So I'm going to go back here. The 2 that were the same went the bottom left, the top right. So that's the way I'm going to set up my proportion here. So I'm going to go from hypotenuse to hypotenuse. So 36 over 12 equals short leg to short leg, which is 12 over x. So now I have my proportion set up. I'm going to do my cross multiplying. So I have 144 equals 36x. So then from here, I'm going to divide both sides by 36. And I get x equals 4. Okay. All right, so moving on to the next one, number 5. I'm going to set up my triangles again so that way I can figure out my proportion. Okay, so I'm going to come over here and I'm just going to draw kind of small ones. My 12 represents the hypotenuse of the big one. My X is the short leg of the little one. The 6 is the short leg of the big one and the hypotenuse of the little one. Okay, so very similar to what we had on this last one. So I'm going to set up my hypotenuse to hypotenuse again. So 12 over 6, short leg to short leg, 6 over x. So now that I have that, I'm going to do my cross multiplying. So I end up with 12x equals 36. Divide by 12 on both sides, and I get x equals 3. Okay. All right, great job. Let's keep moving. Next one, number 6. I'm going to do the same thing. I'm going to set up my 3 triangles. A big one, a medium one, and a small one. My x is my hypotenuse of the big one. My 6 is the short leg of the small one. My 9 is the hypotenuse of the small one and the short leg of the big one. So now that I have those set up, I'm going to go x to 9, hypotenuse over hypotenuse, and then 9 to 6, short leg to short leg. Cross multiply, I get 6x equals 81. Then I divide by 6 on both sides, and I get x equals 13.5. Okay. All right, now just like when we were talking about our Pythagorean theorem, and then we had these special triangles, the 45, 45, 90, the 30, 60, 90. Well, we also have special situations when we're dealing with our similar right triangles. We have 2 of them. We have a geometric mean altitude theorem and a geometric mean leg theorem. We're going to start with the altitude theorem. So what this says, in our right triangle, the altitude from the right angle to the hypotenuse divides our hypotenuse into 2 segments. So here's one, here's the second one, 2 segments. The length of the altitude is the geometric mean. So if you remember, we said that that goes here and here. So the altitude is segment BD. So I'm going to say BD and BD. It's the geometric mean of the lengths of the 2 segments. So we're going to use AD and CD. Those are my 2 segments. So the altitude is the geometric mean between the 2 pieces of the hypotenuse. So we come down here to number 7. My altitude is the geometric mean, so my x goes here, between my 2 segments of the hypotenuse, which are 9 and 6. Okay, so I'm going to cross multiply. I get 54 equals x squared. Now I'm going to take my square root, and I get x equals, well, I don't know what the square root of 54 is. I'm going to have to break that number down. 54. 9 is a perfect square. That was 9 and 6. We had 9 and 6 up here. So I'm going to take the square root of 9 and the square root of 6. Okay, square root of 9 is 3. So this becomes 3 square root of 6. Okay. All right, let's move on to the next one. So our altitude, which is x, we're going to put that as the geometric mean between the 2 pieces of my hypotenuse. That's 8 and 5. So now we're going to cross multiply. So we get x squared equals 40. Take the square root of both sides. X equals, well, what are my different factor pairs for 40? So 40 breaks down. I need perfect squares. 4 and 10 would be a perfect square. So 4 breaks down to 2. So this is 2 square root of 10. My 10 doesn't break down any farther. There's no perfect squares that go into that. All right, so that's one of our special ones. The other one is our leg theorem. So now we're going to be looking at the legs. So for this one, in a right triangle, the altitude from the right angle to the hypotenuse divides our hypotenuse into two segments. That's what it said before. The length of each leg of the right triangle is the geometric mean. So now we're looking at the legs. So BC or AB. So we've got two different situations here. That's the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Okay, so we're going to use the whole hypotenuse this time. So that's going to be the same for both. Then we want the piece of the hypotenuse that is adjacent to BC to come down here. So which one of these two pieces is adjacent to leg BC? Well, that's going to be this side over here. So that's CD. If I'm looking at AB, well, now this piece is adjacent to AB. So AD would go with this proportion. Okay, so it's the leg is the geometric mean between the whole hypotenuse and the piece of the hypotenuse that's adjacent to it. So if I was looking at AB, AB is the geometric mean between the whole hypotenuse and the piece that's adjacent to it. Okay, let's do a couple examples. So number 9, X is the geometric mean between the whole hypotenuse, a whole thing, which is 20, and the piece that's adjacent to X, which is 9. Okay, so I'm going to do my cross multiplying. I get X squared equals 180. 20 times 9, 180. So now I'm going to do my square roots. So I get X equals, well, I don't know what the square root of 180 is. So I'm going to have to break that down. So 180, well, I know 9's going to go in there, and 9's a perfect square. 9 and 20. Can I break 20 down further, though? So we could also do, this would be 4 and 5. So square root of 9 is 3. The square root of 4 is 2. And then I still have my square root of 5. 3 times 2 is 6. And then I'm still left with my square root of 5. So 6 square root of 5. Okay. All right, let's try one more. So on this last one, we've got our leg is the geometric mean. So we're going to put the X here between the whole hypotenuse, which is 8, and the piece that's adjacent to it. Now the piece that's adjacent to it, we don't know that number. We know the whole thing is 8. We know this part is 2. So this has to be 6. So 6 is the other number that's going to go on there. Now we're going to cross multiply. We get X squared equals 48. Take the square root of both sides. So we get X equals, again, I'm going to have to break 48 down. So 48 breaks down into what pieces? Well, let's see. 4 is going to go in there. 4 will go in there 12 times. 12 breaks down to 4 and 3. So square root of 4, square root of 4, and a square root of 3. Square root of 4 is 2. Square root of 4 is 2. And then I have a square root of 3. 2 times 2 is 4. And then, like I said, I'm left with that square root of 3. So 4 square root of 3 would be my answer. Okay? Like I said, you can always look for bigger ones, but if you know those little ones, you can just break it down multiple times. Okay? All right, so that's all that I have for that. We will be doing a maze in class, and then we'll have some practice problems. So I hope that you have a great day, and I will see you in class.